once again I will tell you about the derivatives of some standard functions. These formulas, uh, you can remember these derivatives of some standard functions. Again, this part I am repeating. Number one, d by dx of a constant number. If a constant number is alone, not with the function, only a constant number, any number, if you want to differentiate any constant number or which will come in any question, your differential will be 0. Differential of a constant number is 0. Differential of x to the power n d by dx of x to the power n is equal to nx n minus 1. Third, if constant is with some function, suppose you have a constant with some function c and x to the power n, then c we can take out common and we will differentiate this nx, so that will be nx n minus 1. Okay, then you know that the differential of, we have seen yesterday also, the d by dx of sin x is equal to cos x, and d by dx of cos x is equal to minus sin x. This you remember, because when you remember differentiation, then integration, in integration all formulas will be reverted. So in that reverse order you have to, you can easily remember from this. Otherwise there will be a problem when you start integration. So tan x square is equal to sec square x, and d by dx means differentiation of your derivative of cos sec x is equal to minus cos sec x cot x minus cos sec x cot x. Similarly, d by dx of sec x is equal to sec x tan x, sec x tan x, and cot x d by dx of differentiation of cot x is minus cos sec square x minus cos sec square x. Tan x is sec square x, cos sec x will be minus cos sec square x. Sec x will be sec x tan x, so cos sec x will be minus cos sec x cot x. Then d by dx of e to the power x, e to the power. This is the only function whose differential is the same. And d by dx, this you should remember that d by dx of a to the power x. A to the power x, x to the power n means here function to the power constant, and here constant to the power function. Then it will be a to the power x log a to the base e. Like if you have to find, suppose x d by dx of x to the power 5, you can easily find by using this formula 5x raised to power 5 minus 1, 5x raised to power 4. But if you have to find reverse of this, d by dx of 5 to the power x, then you have to use this log formula. This will be 5 to the power x log 5 to the base e. Okay, so this is the difference between these two formulas. Then 12 log x. If you have to find the differential of log x, when generally log of function, then the base is e always. So log x is equal to 1 by x, where x should be positive, greater than 0. Otherwise, it will become infinity. And the last one is, I'm writing here, there are many formulas, but actually we are taking in parts. We cannot take together. In this part, then we will do the questions on these formulas. This is the difference. Here the base of log is exponential. Here the base of log is a. A means any constant. If d by dx of log x to the base a, then its differential will be 1 upon x log a. 1 upon x log a to the base e. This a will convert into e, where a is positive, a is greater than 0, and a should not be equal to 1, because log 1 is equal to 0 and 1 upon 0 will be infinity. That's why. So these are the formula that we have used already before. Now there are some rules that is called algebra of derivatives. So because in the first exercise that we have done yesterday, so there I left two questions because of the quotient and the product rule. So today I will tell you all the rules, then we can start the exercise. Algebra of derivatives, sum and difference, as I told you yesterday also, that sum and difference, in sum and difference derivative can go inside directly. So and sum and difference of sum and difference rule, you can say. Sum and difference rule. Sum and difference rule means if you have uv be the functions of x. For every one we are taking here, let u is a function of x and v be a another function of x. Both are the functions of x. Then d by dx of their sum or difference we can write together, whether it is sum or difference. If it is plus or minus, so either we add them and then differentiate, or we can differentiate them separately and then add. So this d by dx, in simple, d by dx will directly go inside with, there is no any other rule will be followed. Only just will go d by dx like the sim, uh, simple operators. Then product. Now product and quotient rule are different. That you have to remember. It's very important. So this product rule, or someone says UV rule also, but this is product rule or Leibniz rule. It's called product rule or Leibniz rule. In this rule, UV are the two functions of x. They should be the function of the same variable x. If it is y, we will differentiate with respect to y, d by dy. So then product rule says that if you want to find the differential of the product of two functions, u into v, u into first you have to leave the first function. You can leave the first function as it is, and then differentiate second function d by dx of v plus, you have to leave the second function, plus will come here. Remember. Then you leave v and differentiate u. And this is because of the plus, this is symmetric formula. If you differentiate v first, it doesn't matter. U first, it doesn't matter. So this will be used. How it will be used? Suppose you have to find the differential of two functions d by dx of, let's say, product of the two functions e to the power x into sin x. This you have to find. Then what will you do? First function as it is, e to the power as it is, differential of second function dy dx of sin x, plus you can leave sin x now, and dy dx of e to the power x. So e to the power x, differential of sin x is cos x, plus e to the power x, differential of e to the power x is e to the power x. I'll write first and then sin x. Now you want to solve further, you can take it out common, e to the power x to cos x plus sin x. So like this it will be used. But the most important thing is the quotient formula. And here this is a symmetric, for one is symmetric. If you will reverse the order, it will not change. So, but in quotient rule, you have to use the order, same order in quotient rule. Quotient rule means in division. If you have to find the division of two functions u by v, numerator upon denominator. So remember, you will first write v. It is important to write v first, denominator first, then differential of numerator dy dx of u, then minus will come. Now leave u, and then differential of v, d by dx of v. Okay. Then whole divided by the square of the denominator. Okay. So you can also write denominator, or you can say that denominator differential of numerator. You can write for more understanding denominator. First you will write always denominator, then differential of dy dx of numerator minus numerator and d by dx of denominator whole divided by whole divided by the square of the denominator. Denominator's square. This will be used like this. If you have, I'll give you an example, d by dx. If you have to find d by dx of same example, e to the power x upon sin x. Okay. So these are the two functions in quotient. So denominator, first you will leave the denominator. That means sin x. You have to leave sin x first, and then differential of e to the power x minus e to the power x, differential of sin x. differential of sine x and whole divided by whole square of sine x. Whole square of sine x and sine square x, same thing. Either we write sine x whole square or sine square x. Same thing, doesn't matter. So we can write sine square x. This is the answer. And e to the power x, the differential of e to the power x is equal to e to the power x. So e to the power x will be written in sine. Differential of sine x is equal to cos x. Cos x. Okay. Now you can take out common e to the power x. So finally you get e to the power x into sine x minus cos x divided by sine square x. So these are the two rules that you have to remember. So now, and chain rule I told you yesterday, not going to tell you again chain rule. And now two questions were left because of these rules. So we can have that question. Uh, Exercise 5.2. Question number 5th and 6th. 5th and 6th were left yesterday because of these two formulas. Now you can see this question numbers in question number 5. We have to find the derivative of question number 5. So we used to write y is equal to whatever given. We used to write y is equal to. We have given question number 5. We are doing y is equal to sine a x plus b divided by cos dx plus d. Chain rule will be applied afterward. First we have quotient rule. So how we will go? First we will differentiate. We will write differentiate both sides with respect to differentiate with respect to x because this is a function of x. So dy by dx that is called derivative and d by dx of these two functions. So you have to check that outermost functions are in which order, in which condition. It is in the quotient rule. It is in numerator and denominator separately. It is in numerator and denominator, not the composite one. So first you will use the numerator denominator formula. So you have to leave the denominator as per the formula cos cx plus t and then differentiate d by dx of sine ax plus b. Sine ax plus b minus leave sine ax plus b and differentiate d by dx of cos cos dx plus d, and this is divided by cos square dx plus d. Okay. Now chain rule sine ax plus b. I told you this is a chain rule. Outermost first of all, what will you write if you write the question sine? First you will write sine, so you have to find the differential of sine. First you will write the differential of sine, then you will go inside that. Okay. So first you will write the differential of sine is what? Cos, as I told you yesterday, cos ax plus b. Okay, then you go inside, you will find ax plus b. So the next step will be the d by dx of ax plus b. Ax plus b. This is the chain rule, huh? That is chain rule. We have done many questions yesterday. And minus sine ax plus b. Similarly, ax plus b as it is, and outermost is cos. Its differential is minus. So Either you write here minus in bracket, or that minus and this minus will become plus, and you can write the differential of cos is sine Tx plus d, and go inside this function, you will find Tx plus d. So then Cx differential of Tx plus d, Tx plus d, and this is whole divided by, this whole is divided by, you can write like this also, divided by cos square Tx plus d. Now you can solve this Cx, cos differential of ax plus b d by dx will go inside. Actually, this also you should write, but we are doing actually directly sometime. Otherwise, it will be a big question, is big solution. We can write now. It will go d by dx, but it is a starting, so you should use all the steps of ax. D by dx will go inside. We have seen sum and difference rule, d by dx of b. Okay, then a is constant, so a is outside, d by dx of x, d by dx of x plus b is a constant, its differential is 0. D by dx of x is 1, because it is, if it is 1, it is 1 already. So we can use the formula x n minus 1, 1 minus 1, 0. So 1 minus 1, 0 means a x is to power 0, that is equal to 1, so it is equal to a. Or you can say dx is always cancelling 1. So d by dx of x is always 1. You can remember directly also. So a. So we will get only a here, and here we will get only c. So that is the final result. Here a will come, so we can write in the starting a cos cx plus c, cx plus c into cos ax plus b into cos ax plus b. This we have written already. Here the differential will be c. So in the starting you can write c sine ax plus b into sine cx plus d in whole divided by cos square cx plus cx plus d. Okay. When you are using this slash, you should use the bracket, for all these numbers are divided by this. Okay. So similarly, this is the product. This is the quotient rule. Now product rule. You have the next question. Cos x cube. Sixth question is cos x cube y is equal to cos x cube, cos x cube into sine square x raised to power 5. Sine square x raised to power 5. See this, we have the product between the two functions. Then we have composite functions. So similarly, we will differentiate both sides with respect to x. We get dy by dx, and then product rule will be applied. D by, first you can write dy dx of, so we used to write like this, and whichever is the first function, we are considering first function into second function, sine square x raised to power 5. So first second also we can write first function differential of second function plus second function differential of first function. So first function as it is cos x cube, then differential of second function d by dx of sine square x raised to power 5 plus leaving sine square x raised to power 5 and differentiate the first function d by dx of cos x cube, and this is whole divided by the square of the, oh sorry, not sorry, product rule. So that is the product rule. That's it. Only here, whatever I told you, that if you remember yesterday, I told you whichever is the outermost function. So yesterday I asked that under root cot x cube. So what I have written first, under root, that is the outermost function that will be differentiated first. But only this is not followed here. I see that, because we have to write sine first, then square x. But the outermost is the power. This sine x raised to power 5 as whole power. So outermost function is square, not the sine. But when we are writing sine first. So this type of function, you should see that if power is there, then power will be the outermost function that will be differentiated, and then you go inside, you will find sine, then you go inside, you will find x raised to power 5. So like this we will do it by the chain rule. So cos x cube. So you can see that now square. What is the differential of a square? Dy dx of x square. Any function square is 2x. 2x is equal to 2 minus 1. 2 minus 1, that means 2x. Okay. So here also sine whole square will be 2 sine x. 2 differential of this will be 2 sine x raised to power 5. Then we go inside. What is the inside function? Sine. So then we have to differentiate d by dx of sine. Square has differentiated already, so leave it. Sine x raised to power 5. Similarly, here simply cos is the outermost function, so we first differentiate that one. So differential of cos is minus. This plus will become minus. This plus will change to minus because of that differentiation. So we can make it minus, or we can write here plus, and then here you can write minus. Actually, when you are writing minus here, you cannot write like this. You have to make the bracket, because it is in multiplication dot. So differential of cos x is sine x. So sine x cube. Then inside function is what? X cube. Differential of x cube dy dx of x cube. It has only two functions, so it will be differentiated in 2 times. Here you have 3 functions: square, then sine, then x raised to power 5. So 3 times it will be differentiated by doing 3 times. So now, okay, 2 sine x raised to power 5, you can write as it is. Differential of sine. Now outermost is sine, so differential of sine is cos x raised to power 5, then go inside x raised to power 5, then differential of x raised to power 5. The third function will be differentiated. This plus minus, now you can multiply and write plus minus minus, and sine square x raised to power 5 into sine x cube, sine x cube, and differential of x cube is 3x square, n x n minus 1, 3x square. Now again one differential is left. X raised to power 5 will be 5x raised to power 4. So numbers we can write in the starting 2 and 5. 5 will also come 5. So 5 to the 10. I can write directly 5 to the 10. After differentiating, you will get 10 here. Huh? 5 to the 10 x raised to power 4, because differential of this will be 5x raised to power 4. Then cos x cube sine x raised to power 5 into cos x raised to power 5 minus 3x square. You can write in the starting 3x square into sine square x raised to power 5 into sine x cube, into sine x cube. This is the final solution. The product, when you have to see that whenever first product is given, you have to apply the product. Okay. Next part we have actually implicit functions, derivatives of implicit functions. What are implicit functions? I'll tell you. Implicit functions, derivatives of implicit. How will you do derivative of of implicit function? So you can rejoin 1 minute left. Otherwise, we will rejoin now only without any gap. Rejoin.